Occupied France, August 1943, on a remote Luftwaffe airfield just after 400 hours. Oberleutnant Vera Schultz, Chief Technical Officer of Jagdschade 26, received a piece of news that should have been a triumph. American P-47 Thunderbolt had been forced down, its pilot captured, and the aircraft itself was largely intact. This was intelligence gold for months. German pilots had been encountering this massive American fighter, reporting capabilities that seemed impossible. Now, German engineers would finally have a chance to examine one up close. When engineer Oberleutnant Schultz's initial reaction to the P-47, Schultz saw the P-47 on the tarmac. His initial reaction was the same as every pilot's. It was grotesque, an obscenely fat and ungainly flying milk bottle. But as he began his methodical examination of the enemy machine, the engineer, who believed in numbers, was about to uncover a devastating truth. The P-47 wasn't grotesque. It was a prophecy, and its components were a mathematical proof that Germany had already lost a war its leaders didn't even know they were fighting. Schultz was not a combat pilot. He was an aeronautical engineer who had worked for Messed before the war. His job was to understand enemy aircraft, identify weaknesses, and recommend tactical countermeasures. When he arrived at the airfield and saw the P-47 for the first time, his initial reaction was the same as every German pilot's. This thing was grotesque, obscenely fat, and comparison P-47, 8 tons, versus FW-190, 4 tons, ungainly. The fuselage was massive, built around an enormous radial engine. The aircraft weighed nearly 8 tons fully loaded. For comparison, the Fowler Wolf FW-190, Germany's frontline fighter, weighed about 4 tons. German pilots had nicknamed it the Fliegen Flasher, the flying milk bottle. Looking at it sitting on the tarmac, Schultz understood why. It looked like it had no business being in the air. But Schultz was a scientist. He didn't care what it looked like. He cared what it could do. And Ash began his examination. What he found would shake him to his core. Schultz, the heart of the machine. The Pratt Whitney R-2800 double wasp engine started with the heart of the machine, the Pratt Whitney R-2800 double wasp engine. When his team removed the cowling, they stood in silence for a long moment. The engine was enormous, 18 cylinders arranged in 2 rows of 9, creating a radial configuration that explained the P-47's bulky appearance. But size alone wasn't what stunned Schultz. It was the quality, the precision, the engineering sophistication. Every component was machined to tolerances that German factories were struggling to maintain. The cylinders were uniform, perfectly balanced. The crankshaft was a masterpiece of metallurgy. Schultz pulled out his notebook and began calculating. Based on the displacement, the staggering power disparity, 2000 HP versus 1700 HP design, this engine was producing at least 2000 horsepower, possibly more with the turbo supercharger system he could see integrated into the fuselage. For comparison, the BMW 8001 radial engine that powered the FW-190 produced about 1700 horsepower at maximum output, and that was pushing German engine technology to its absolute limits. The Americans were mass-producing engines with 20 to 30% more power and doing it with apparent ease, but it got worse, much worse. Schultz, no manufacturing. Shortcuts, evidence of abundant resources, examined. The engine's construction for signs of shortage accommodations. The kind of compromises German factories were increasingly forced to make. Lower-grade materials, simplified manufacturing, anything to save resources. He found none. This engine was built with high-grade aluminum alloys, precision bearings, components that showed no evidence of material shortages or manufacturing shortcuts. It was built the right way, not the expedient way. One of Schultz's assistants, a mechanic who had worked on German aircraft for years, pointed to the cylinders.
Oberleut, look at this.
Each cylinder is individually removable. If one is damaged, you can replace just that component without disassembling the entire engine. Schultz nodded slowly. It was brilliant design. It meant faster repairs, less downtime, more aircraft operational. German engines required extensive disassembly for major repairs. This American design assumed that maintenance would happen frequently and needed to be efficient. The unmatchable turbo supercharger system. But there was something else that caught Schultz's attention. Something that made his stomach tighten with dread. The real secret of the P-47's performance wasn't just the engine. It was the turbo supercharger system. Schultz had read intelligence reports about this, but seeing it in person was different. A complex network of ducting snaked from the engine down through the fuselage tow turbine mounted in the rear of the aircraft. The system used the engine's exhaust gases to spin a compressor at over 20,000 RPM, forcing pressurized air back into the engine. The engineering was staggering. The exhaust had to be channeled through ducting that could withstand extreme heat. The turbine had to spin at speeds that would tear apart inferior bearings. The entire system had to be precisely calibrated to avoid the technical impossible. Why Germany couldn't replicate the system damaging the engine? German engineers had experimented with turbo superchargers, but they'd never successfully fielded one. The technical challenges were too great, the materials too difficult to source, the manufacturing too complex. But here it was in an American fighter that was being mass-produced, not a prototype, not an experimental aircraft, a production model, one of hundreds or thousands. Schultz did the air dominance P-47's performance at high altitude calculations with this turbo supercharger. The P-47's engine could maintain full power at altitudes where German fighters were gasping for air. Above 25,000 FT, the FW-119 and Bf-109 lost significant performance as their mechanical superchargers struggled in the thin air. The P-47 would be hitting its stride, fast, powerful, and completely dominant in the high-altitude realm where German fighters had to operate to intercept bomber formations. His assistant asked the obvious question, can we replicate this system? Herr Oberleutnant, Schultz shook his head, but with our current manufacturing capacity. This system requires precision machining, high-grade steel alloys, and thousands of man-hour of skilled labor. We're already struggling to produce enough basic aircraft. Adding this level of complexity, he paused. It's beyond our capabilities. The realization was crushing. The Americans hadn't just built a better fighter. They'd built a fighter that presented a level of industrial sophistication Germany couldn't match. After examining the engine, Schultz, the airframe, incredible durability and battle damage, absorption turned his attention to the airframe itself. What he found was equally disturbing. The P-47 had taken significant battle damage. Cannon shells had torn through sections of the fuselage. Machine gun fire had riddled the wings. And yet the aircraft had flown back and made a controlled landing. Schultz examined the damage patterns. Multiple 20-mm cannon hits, the kind that would typically shred a German fighter. But the P-47 structure had absorbed the hits. The heavy-gauge aluminum skin, the robust internal framing, the redundant control systems, all contributed to incredible durability. He pulled out damage reports from Luftwaffe units. Time and again, pilots reported pumping cannon fire into P-47's and watching in disbelief as the American fighters continued to fly. Their reason was evident. The P-47 was built like a tank, where German fighters optimized for weight savings and agility. The P-47 was designed to absorb punishment and keep flying. The cockpit armor was extensive. Thick steel plates protected the pilot from multiple angles. The windscreen was armored glass, far thicker than anything in German fighters. But most importantly, the radial engine as a shield, durability versus German liquid. Cooled engines, the R-2800 radial engine served as a massive shield. Unlike the liquid-cooled inline engines in the BF-109 and FW-190, the Radial had no vulnerable coolant system. You could shoot cylinders off the engine, and it would keep running. Schultz found documentation showing that P-47s had returned to base with multiple cylinders destroyed, fuel tanks punctured, and control surfaces shot away. German fighters with similar damage would have fallen from the sky. One of his engineers made an observation. It's over-engineered. They've added weight for durability that could have been used for performance. A fundamental difference in design, philosophy, mass versus optimization. Schultz nodded. Yes, but they can afford. They have engines powerful enough to carry the extra weight. We don't. We have to optimize for weight because we lack the engine power to overcome it. It was a fundamental difference in design philosophy. Germany built aircraft at the edge of what was technically possible, squeezing every ounce of performance from limited resources. America built aircraft with massive safety margins, compensating for any inefficiencies with brute force. And brutally, the American approach was working better. Schultz examined the devastating firepower 8 Browning 50 caliber machine guns, P-47's armament next. 8 Browning M250 caliber machine guns, 4 in each wing. His heart sank as he calculated the implications. Each gun had approximately 400 rounds of ammunition. Total ammunition load 3,200 rounds. Rate of fire for all 8 guns combined, over 100 rounds per second. The firepower was devastating. A 1-second burst would put 100 heavy slugs into a target. A 2-second burst, which was typical for a firing pass, would launch 200 rounds. German fighters typically carried 2 or 4. Machine guns plus 1 or 2 cannon. Total firepower was less and ammunition was more limited. A BF-109 might have 60 rounds for its cannon, 500 for its machine guns. Once that was expended, the pilot had to return to base. The P-47 pilot could fire almost continuously for 30 seconds. In practice, that meant multiple long bursts across several engagements before running out of ammunition. But it wasn't just the quantity. Schultz examined the 50 caliber rounds themselves. They were heavy, high-velocity projectiles that could punch through armor and structural components with ease. He'd read reports from pilots describing the effect of P-47 fire as a wall of lead. Now he understood why. With 8 guns converging at a focal point, anything caught in that cone of fire would be shredded. German aircraft, with their lightweight construction and limited armor, would disintegrate under this kind of firepower. A P-47 didn't need to be precise. It just needed to get the target generally in front of it and pull the trigger. Schultz made notes. Recommendation: avoid head-on engagements with P-47. Probability of surviving return fire minimal. As Schultz's conclusion of technical superiority and the staggering industrial capacity compiled his technical report, he began to see a pattern that went beyond any single component. Every system on the P-47 spoke to an underlying industrial capacity that was staggering. The engine required precision machining and high-grade alloys. The turbo supercharger required advanced metallurgy and manufacturing. The airframe required massive amounts of aluminum. The armament required a functioning ammunition production industry. Any one of these components would strain German industry. The P-47 had all of them integrated into a single aircraft and was being mass-produced. Soul-crushing production rates, 500 plus P-47s per month. Schultz requested production data from intelligence sources. What he learned was soul-crushing. Republic Aviation was building P-47s at a rate that seemed impossible. By late 1943, they were producing over 500 aircraft per month. Plans called for ramping up to 600, 700, even 800 per month by 1944. For comparison, German factories were struggling to produce 300 to 400 single-engine fighters per month, total across all types. And German production was constantly disrupted by Allied bombing, but the numbers got worse. The R-28,000, the R-2800. Engine production, 125,000. Units engine wasn't just used in the P-47, it powered multiple American aircraft. Total production of R-2800 engines would exceed 125,000 units during the war. 125,000 of these 2,000 horsepower engines. Germany's entire production of aircraft engines for all types across the entire war would be roughly 250,000 units, most of them significantly less powerful. The Americans were building more of a single advanced engine type than Germany could produce total engines. Their disparity was incomprehensible. Schultz sat at his desk staring at the numbers. He ran the calculations again, thinking he must have made an error. But the numbers didn't change. American the 3-1 aircraft production. Ratio aircraft production for 1943 was projected to exceed 85,000 aircraft. German production would be about 25,000, a ratio of more than 3.1, but it was worse than that because American aircraft were on average heavier and more complex. A single B-7 bomber required more aluminum and man-hour than 3 Bf-109 fighters. The Americans were building thousands of B-7. The material disparity was overwhelming. America was fighting a global war, supplying the Soviets with thousands of aircraft and tanks, equipping British forces, and still outproducing Germany, Schultz's dangerous final report and defeatist conclusion in every category. Schultz's final report was due to be presented to High Command in Berlin. As he compiled his findings, he knew he was writing something dangerous. The report documented the P-47's technical superiority in multiple areas. It acknowledged that Germany lacked the industrial capacity to produce equivalent systems, and it contained a conclusion that would be seen as defaced. His summary read, "The P-47 Thunderbolt represents a level of industrial and technological sophistication that exceeds Germany's current capabilities. Its widespread deployment suggests American production capacity far exceeds previous intelligence estimates recommendation. Tactical adjustments to minimize engagement with P-47 at high altitude. Strategic assessment continued attrition against numerically and technically superior enemy aircraft will result in unsustainable losses. In other words, we can't beat this, and if we keep fighting the same way, we'll be destroyed." Schultz's commanding officer read the report and looked at him with a mixture of respect and concern. "You know this will not be well received in Berlin. They don't want to hear that American aircraft are superior. Should I alter the findings?" Schultz asked, already knowing the answer. "No, the report is accurate, but prepare yourself." The leadership doesn't respond the rejection of reality and dismissal of the report well to uncomfortable truths. The report was forwarded up the chain. Schultz never received an official response, but he heard through informal channels that it had been dismissed as overly pessimistic. One staff officer reportedly said, "This engineer has been demoralized by enemy propaganda. The P-47 is crude American engineering, inferior to our designs." Schultz wasn't surprised. He'd seen this pattern before. Intelligence that contradicted Nazi ideology was rejected regardless of its accuracy. But for Schultz personally, the examination of the P-47 had been a revelation, not just about the aircraft, but about the war itself. In the months predictions come true, German losses. Following his report, Schultz watched his predictions come true. P-47 appeared in increasing numbers over Europe. German fighter losses mounted. Experienced pilots were shot down and not replaced. The tactical recommendations he'd made, avoiding high-altitude engagements and using hit-and-run tactics, were slowly adopted, but by then it was too late. The Americans had achieved air superiority through sheer weight of numbers and technical advantage. Schultz's other captured aircraft tell the same story. Industrial war examined other captured American aircraft. Each one told the same story: superior materials, sophisticated systems, evidence of an industrial base operating at a scale Germany couldn't match. He saw a captured C-47 transport plane. It was one of over 10,000 that would be produced. Germany's entire transport fleet was a few hundred aircraft, mostly obsolete designs. He examined a P-51 Mustang. It combined the range of the P-47 with even better performance. The engine was a Packard-built Rolls-Royce Merlin produced under license in America. Thousands of them, every aircraft he examined reinforced the same conclusion. Germany was losing an industrial war to an enemy with overwhelming material superiority. What haunted Schultz was that this information was available. Intelligence existed. German agents were reporting on American production. Captured equipment proved the quality, but the leadership refused to accept it. Or more accurately, they accepted it, but believed that German will and superior tactics could overcome material disadvantage. Schultz had been trained as an engineer. He believed in numbers, in mathematics, in physical reality, and the physical reality was undeniable. Germany was being buried under an avalanche of American steel. After the war, when production figures were declassified, Schultz's estimates were conservative. He'd actually underestimated American capacity. Total American aircraft production from 1940 to 1945, over 300,000 aircraft. German production in the same period, approximately $94,000. The United States produced over 15,600 P-47 Thunderbolts alone, more than Germany produced Bf-19s and Fw-19s combined. The R-2800 engine that Schultz had examined with such awe in 1943. Over 125,000 were built not just by Pratt and Whitney, but by Ford, Chevrolet and other automotive companies converted to war production. The industrial mobilization that produced these numbers was unprecedented in human history. American factories that had been making cars were retold to make aircraft engines. Shipyards that built freighters were building aircraft carriers. And it wasn't just quantity, the quality remained high. Late-war American aircraft showed no signs of declining standards, no shortcuts, no compromises forced by material shortages. German aircraft, by contrast, showed increasing evidence of resource constraints, lower-grade materials, simplified construction. Quality control issues as experienced workers were drafted and replaced by forced labor. Post-war interrogation. We could not win an industrial war. Schultz survived the war and was interrogated by American technical intelligence officers. They were particularly interested in his 1943 report on the P-47. Did you really conclude from examining own aircraft that Germany would lose the war? An American officer asked. Schultz thought for a moment before answering. I concluded that Germany could not win an industrial war against America. The P-47 was evidence of a production capacity we couldn't match. Every component, every system required resources and manufacturing capability that exceeded Germany's total capacity. But you were just one engineer. Surely others reached the same conclusion. Many did. But in the Third Reich, stating inconvenient truths was dangerous. Better to remain silent than to be accused of defeatism. The American officer nodded. We found your report in captured German files. It was marked filed. No action required. Did that surprise you? Schultz laughed bitterly. No, I expected it. The Nazi leadership didn't want intelligence. They wanted validation of what they already believed. When reality contradicted ideology, reality was dismissed. The story of Vera Schultz and the microcosm of strategic failure. Truth, subordinate to ideology. The captured P-47 is a microcosm of Germany's strategic failure. A trained engineer examined enemy equipment, reached an accurate conclusion about Germany's industrial disadvantage, and was ignored. His experience paralleled that of Admiral Canaris, who warned about American industrial capacity, Albert Speer, who knew Germany couldn't win a production war, Adolf Galland, who recognized the P-47's tactical superiority, Essep Dietrich, who knew the Ardennes offensive would fail for lack of fuel. In every case, competent men saw the truth and were trapped in a system where truth was subordinate to ideology. They provided accurate assessments and were dismissed as defeatists or pessimists. The Nazi regime was built on the premise that German racial and cultural superiority would overcome any material disadvantage, that Will and determination mattered more than industrial capacity. That ideology could defeat mathematics. They were wrong. And men like Schultz knew they were wrong from the moment they examined the evidence. But knowing the truth and being able to act on it are different things. Schultz's report on the final numbers, the overwhelming scale of American production P-47, should have been a wake-up call. It should have triggered a fundamental reassessment of Germany's strategic position. Instead, it was filed away and forgotten. The P-47 went on to become one of the most produced fighters of World War II. Over 15,600 were built. They destroyed thousands of German aircraft. They supported the invasion of Europe. They helped achieve air superiority that made Germany's defeat inevitable. And it all started with one engineer examining one captured aircraft and realizing that this nation had already lost a war they didn't know they were fighting. Not a war of soldiers or tactics, but a war of factories and resources. A war where the side with more oil, more aluminum, more steel, and more industrial capacity would inevitably win. America had all of those things in abundance. Germany had none of them.